Okay, what we have here is our front-end application that is leveraging Google Cloud Services and the Vertex AI environment, as well as the Gemini Pro LLM and the AtScale semantic model and capabilities. So if you're a business user, you may have a query about a particular data set, and you may have a report that is provided weekly, daily, monthly, or in some sort of repetitive nature. So you can simply select how many rows are in a data set. And the current data set, based on the semantic layer output, will contain 161,000 rows of oil and gas production data in the state of Texas. But let's say we want to dig deeper and we want to know what are the top 10 producing counties in 2020. We can simply ask this information, and then behind the scenes, the application is calculating who the top 10 oil producing counties were in 2020. We can go a step further with calculated measures and KPIs that are provided through AtScale semantic layer. And for instance, we want to provide any operators that produced over 50 million barrels of oil. A very simple filter function that will provide any of the operators in the state of Texas that are producing over this amount of oil. So you can see here in 2019, these are the operators that produced over 50 million barrels of oil. To take it a step further, we can try to provide the year-over-year production and ask a question to the application for the year-over-year production for top 10 operators over 2015 to 2021. As you can see, the year-over-year production for the top 10 operators in the state of Texas is provided as a yearly output. Now, you didn't need to have a coding background to provide an MDX or query. You simply have natural language processing and the capabilities of the semantic layer to provide this information with a simple statement. This capability is extended to not just numeric or tabular data, but also text information, obviously. And so let's say that you have a custom query and you have some ad hoc analysis that needs to be accomplished quickly. And let's say that the user has no experience with the semantic layer or with MDX language and just wants to learn more about what is MDX and what are the benefits of that. So if we provide and enter in a query that provides benefits of using MDX within OLAP and database environments. As you can see, the query, the custom query, provides a substantial response for how MDX, or multidimensional expressions, are used in OLAP and its similarities with SQL. So users can then gain a quick understanding of why MDX is used within the semantic layer and for processing multidimensional expressions. The custom queries in this case aren't limited to just text responses. If we want to provide a query based on the tabular data set and the contextual information from the Texas Railroad Commission, we are able to do that as well. So let's provide the top counties. Now we looked in, I believe, 2019. Let's provide the top counties oil production totals for 2020. And you can see here that it returns the top counties oil production and a top 5. If you would need top 10, or top 15, you can simply adjust the query as needed. So as you can see, this is a very powerful tool that can quickly and effectively allow analysts and subject matter experts to run ad hoc analysis, as well as the run the business reporting that is common for daily, weekly, and monthly reporting. All right, so now that we've seen the front-end application, let's dive behind the scenes and look at a notebook application for how all of the MDX and the semantic layer is being created for the use in this application. Not only are people that do not have a coding background or that may have just subject matter expertise in a particular area use LLM capabilities, but if you are a data scientist or code first analyst, you can also leverage these capabilities very quickly and easily. So in order to leverage at scale with the semantic layer with GCP, we need to connect to GCP's Generative AI Studio. And we do this through loading the necessary libraries into the notebook, providing our authorization and our credentials, and then initializing a project within the AI platform and within the Vertex AI environments. Second, we connect to AtScale in our semantic layer via the AI link. We import the necessary libraries, we sign into AtScale, and then we sign in and select the project of reference that we'll be using. So once we've selected the project, the semantic model is uploaded and ready to be used within the notebook. This image below demonstrates the complexity of the semantic layer for the data sets involving the Texas Railroad Commission. So as you can see here, there are county level information, well level information, operator names, date, time, and space dimensionality, as well as calculated fields. Now, all of these are being connected and linked together within the semantic layer. And all of this is now loaded into the notebook for use with LLM capabilities. So to better understand the complexities of this semantic layer, we're able to load hierarchies with simple commands that allow us to provide information that we can use to specify in our prompts later on in the notebook. In this case, we're going to be focusing on the date dimension hierarchy, and in particular, year and year month. Once we have the hierarchies and an understanding of the hierarchies, we can then create a data frame from the semantic layer. And in this case, we are looking at district and county information, operators, and obviously the county oil production. And we're filtering it on the top 10 operator names in the state of Texas for the purposes of this demonstration. So once we have our data frame, it is now simply prompting and generating the responses using Gemini Pro. Now, again, the great aspect of Gemini Pro is that you can use this for query and text languages. So, for instance, describe the MDX query language and why is it useful for OLAP. Similar to what we had as a response for the front-end application that we demonstrated earlier. Also, let's say we wanted to calculate and accelerate calculated measures using generative AI, and in this case, Gemini Pro. We have our semantic model, and we create a prompt that is simply create a simple MDX expression where county oil production is greater than 50 million, and we're using the tuple syntax within MDX. So when we generate this content, Gemini Pro provides the MDX expression. And now for use with AtScale, we simply extract what we need, which is the filtering mechanism, and we are left with the measures with county oil production greater than 50 million barrels. The notebook has built-in utility and capabilities to make sure that this is a valid MDX syntax for use in the semantic layer. And as you can see here, everything returns the expression and the syntax is valid. So now we are able to write this function back to AtScale. So by creating a new calculated measure named greater than 50 million barrels and a caption of production greater than 50 million, as is demonstrated in the image above, we can return and create a calculated measure within our semantic model. This can be used and previewed within AtScale, and queries can be run against this new calculated measure. And once this is in the semantic model, you can then use it downstream in any sort of end user application or BI visualization tool. And so, as you can see, the differences between the true and false of who has produced 50 million barrels over the last 20 years is easily accessible and available for decision-making capabilities. So I just want to show and recap once again how quickly and easily it is to go from a simple prompt with zero coding background to generate a KPI that can then be validated and leveraged within AtScale. The calculated measures can then be distributed across the enterprise for various dashboards and use.